Hi guys, this is the last lesson, or lesson 4, in the electromagnetic radiation and optics module. It is going to be focusing on diffraction, which is the last light bin that we're going to talk about, and also Young's experiment. So in 1801, Thomas Young found a way to calculate wavelength of light by interference pattern it created. So he set up a monochromatic light source and shot it through two very tiny slits in a screen, and the results were bands of color called bright fringes. Each slit produced a new wave that was the same frequency as the original wave and in the phase of wave from the second slit. You can use those bands to calculate wavelength. So with two waves we get interference patterns. The light areas or dark fringes are areas of constructive interference, and the dark areas or dark fringes are the areas of destructive interference. So we're going to talk now both about constructive interference and destructive interference. So as the new wave fronts were produced at the slits, the wave would spread out to strike the screen. Each ray takes a different path to get to the screen, so if the path difference is a whole number multiple of a wavelength, we get constructive interference. If the path difference is half a wavelength, then the waves are out of a phase and we get destructive interference. So make sure you understand the difference between constructive interference and destructive interference based on those wavelengths that are calculated as they're passing through those small slits. So first, let's focus on the equation for constructive interference. So we have this relationship where you see the formula right here at the top of your screen. D is going to be the distance between the two slits. So you see the D right here on that photo. Q is the angle that the fringe makes with the line from between the slits to the screen. That Q is going to be the angle theta. And so D is the distance between the slits, and angle is that the fringe makes with the line from between the slits to the screen. Okay, so M is the order number, and the bands are ordered starting with the middle having the number of 0, then counting outward. And L is the wavelength of the light. So we also have a similar equation for destructive interference. So we're going to see these two equations when we get to the practice problems. Diffraction is the last characteristic of a wave, or the bending of waves as they travel around an opening or through a barrier. Notice as the ocean waves approach the barrier, they are parallel to it, and as the waves pass through the barrier, it spreads out in the arc. What that's talking about is if you look over here on the picture, these are waves. They're traveling this way. So they're traveling parallel to this barrier, which is, let's say, a rock wall. And as they go through it, you can see the pattern of the waves start to create this arc, or the ripple effect that you see in water sometimes. So it allows sound basically from an outside of the room that can come in and be heard in the entire room. And another example is when you're sitting in your dark room and there's light coming in from the closed door, you notice that the light is spreading out and not staying in a straight line. So here are the practice problems. The first one states that light travels through a medium with an index of refraction of n equals 1.42. What is the speed of light in this medium? So again, we use that formula that we were doing all the other practice problems. We plug in what we know. 3 times 10 to the 8, remember, is that constant of speed of light, divided by 1.42, which is the index of refraction. So we get 2.11 times 10 to the 8th meters per second. Letter B states what is the wavelength as the electromagnetic radiation if it has a frequency of 3.45 times 10 to the 14th hertz. So we use this formula now. And we rearrange to solve for wavelengths, which is this. And we plug in what we know, which is 2.11 times 10 to the 8th, which we got from calculating the letter A, divided by 3.45 times 10 to the 14th, which is the frequency that was given to us in the problem. And we should get 6.12 times 10 to the negative 7th meters. Letter C states that if the light is sent through two slits that are 7.25 times 10 to the negative 5 meters apart, what is the angle of the first order bright fringe? So here we're going to use that new formula that we were talking about earlier in this lesson. We plug in what we know. So it's the first one, so that's where the 1's coming from, times 6.12 times 10 to the negative 7th, which is what we calculated in letter B, divided by 7.25 times 10 to the negative 5th, which is the distance between the two slits. So we should get 0.00844. So now we're going to have to take the negative sign or the inverse of sine to get the angle, and our angle is 0.484 degrees. Again, make sure your calculator is in the correct mode. Practice problem number 2. The electromagnetic radiation is sent through two slits that are 2.44 times 10 to the negative 5th apart. If the fifth order dark fringe is at an angle of 10 degrees, A, what is the wavelength of the electromagnetic radiation? So now we're going to use the destructive formula that we talked about earlier in this presentation. Rewrite it for solving for wavelength, because that's what the problem is asking us to. Then plug in what we know. So the distance is 2.44 times 10 to the negative 5th, sine of 10, which is the angle given to us, divided by 5, and we know the 5 because it's the fifth order ring, plus 1/2, equals 7.70 times 10 to the negative 7th meters. Letter B says, what is the frequency of the wave? So we use our frequency formula, rewrite, that's supposed to be the wavelength. The speed of light, which is that's c, 3 times 10 to the 8th, divided by what we just calculated in letter A, 7.70 times 10 to the negative 7th, and we should get 3.90 times 10 to the 14th hertz. So lots of practice on these practice problems. I think, yeah, that's the last one. Let me know if you have any questions after watching this recording. Make sure you've watched all the videos before taking the test. This is always a good review to do right before your test. Keep up the good work, and thanks for watching.